Hello everyone! Welcome to part 2 of my build video for this incredibly handsome table stop. In part 1 I covered all of the lathe work, and I'm going to show most of the milling and the assembly of the base in this one. I'm also giving away the 3 stops that I made during the course of this video. More on that a little bit later. For now, let's get into the build. The first thing I had to do was cross drill and ream the stop rod collar to fit the stop rod. This hole needs to be right in the middle of the part in both directions, so I'm using my edge finder to locate both sides in each axis. Then I split the difference between the two to find the middle of the part. This seems to be the method of edge finding I do most, because for the vast majority of my parts, knowing the center point is a lot more important than knowing where the edges are. Then I spotted the hole, drilled, and reamed it to 0.376 inches for a slip fit over the stop rod. Since I had to make several of these, I used the table stop I'm recreating to locate my other parts. Likewise, the head of the screw needs to be cross-drilled and reamed. I'm using my square 5C collet block to hold this because the collet won't mess up the threads on the screw. I'm also using the table stop to locate the end of the piece. The hole needs to be the same distance from the end of the part as the hole on the collar. Since the head of the screw is shorter than the collar, this will ensure that it will be able to pinch down on the stop rod when the handle is tightened. Drilling and reaming these parts has caused a lot of burrs to form, so they need some tender loving care with a variety of sharp objects. I used my deburring wheel on the grinder to help out a little as well. The fit on the cross hole is pretty tight, so you may need to run the reamer back through both parts while they're together to correct any misalignment between the parts and allow the stop rod to go through. I'm just holding the reamer in my drill chuck and turning it by hand, but make sure not to run it backwards. That can dull the reamer. Moving on to the base, it needs to be cut to length first, which is 5.5 inches or about 140 millimeters. I'm not touching the width of the stock at all, but that's 2.5 inches or about 63.5 millimeters. Don't forget to thoroughly deburr your edges before placing the stock back in the vise. Burrs can really do a number on your measurements, and they can make the part sit at an angle in the vise which throws off the squareness and parallelism of your features. Once both ends of the base are machined to length, it's time to find the edges. I'm using the edge finder to find the center of the part in the y-axis. When I do this, I zero my DRO on the first side, and after finding side number 2, I use the half button on my DRO to cut the measurement in, you guessed it, half. This does the math for you, not that it's complicated or anything. And then you just need to move to 0 on the DRO, and you're in the middle of the part. For the x-axis, I'm finding that in the usual way because all the dimensions are given from the end of the part. Don't forget to account for half the diameter of the edge finder tip. Once that's done, I'm moving to the site of the bore. That's the most critical feature and therefore the easiest to screw up, so I want to do that first. That's generally good practice because if you're going to totally hose a part, try to do it early on. I'm drilling a pilot hole that's slightly bigger than the chisel point on the large drill I'm using to drill the hole. Most of the pressure from drilling happens at the center of a drill where it isn't rotating very quickly. So taking that material away with the pilot drill makes drilling the larger hole loads easier and results in a straighter hole that is closer to on size. Not that it matters in this case because I'm using a boring head to finish the hole. This could easily be done with a reamer as well, but I don't happen to have an over-under reamer set for this particular size. I'm using my 10th set boring head for this job, which lets me dial in the size using the vernier scale up on top. I'm making my first cut at a convenient spot on the dial and taking an initial measurement. Whenever I use a boring head, I want to make sure I know exactly how that boring bar is behaving. So I take multiple cuts at the same depth with a measurement between each one. This tells you pretty quickly what you can expect out of the cut and is an absolute must if you're shooting for a tight tolerance like we are here. Let's talk a bit about different types of fits. As I said in the first video, I'll be attempting to do a press fit and a shrink fit to show off 2 different methods of attaching the column to the base. For both of them, I'm shooting for the same amount of interference between the 2 parts, between 0.5 thousandth and 1,000th, or 0.013 to 0.025 millimeters. The amount of interference depends a lot on the size of the parts that are getting stuck together, the length of engagement between them, and the material. If you leave too much material, it's going to require a lot more pressure to put them together, especially with larger diameters and longer engagements. Generally, if you're pressing two dissimilar materials together, like a bronze bushing into steel or cast iron, things will go pretty smoothly. But when your materials are the same, like we have here, you have to watch out for galling. This is when the two parts start to smear together, and when it happens, no amount of pressure is going to fit those two parts together without damaging something. Some materials are worse than others, like stainless and aluminum, but it can happen anytime two parts of the same material are pressed together. Like I said at the beginning of the video, I am giving these stops away. 3 lucky people will be chosen at random from among all of my patrons over on Patreon at 5 p.m. Central Time on April 1st, 2022. No fooling. If you want a chance to win one of these dudes and help support the channel while you're at it, head over to Patreon and sign up. Speaking of Patreon, this video is brought to you by the letter R. No, seriously, I have a new patron who only wants to be identified as R. They're joined by a couple of other new faces, Aaron Clark and Dan from Cafe Racer Garage. If you're interested in supporting the channel like them, head over to my Patreon page. The link is down in the description. Let's get back to the project. The slot is pretty straightforward. I drilled a hole at the beginning and end of the slot to avoid having to plunge with the end mill. Then I took multiple 100,000th deep passes until I got through the part. Notice that I'm not drilling a chain of holes to remove most of the material. I see that done a lot, and I gotta say, I'm not a big fan. Constantly breaking out of one hole and into another is very hard on the end mill. That said, this feature doesn't necessarily need to be a slot. It could easily be a single hole or a few different holes spaced out to give you some adjustability. I like the slot because it makes getting the stop into a good position very quick and easy. In the first video, I showed slightly undercutting the end of the column to help get it pressed in straight. Another method is to make a little donut like this that has a hole bored for a slip fit with the column. This will hold the part square while pressing it in and greatly reduce your chances of absolutely shanking this part of the job. Now let's say, just hypothetically speaking, that you f***ed up and made the fit just a little bit too loose. It's still snug, but it's a really light press fit if you can push it in by hand. What are your options in this case? Well, like I said in the first video, you could easily weld this, pin it, or put a set screw in it. I'm going to go with the set screw option, but I'm also going to use Loctite on it. This is an anaerobic adhesive for bonding metals together, and it comes in several varieties. There's blue Loctite, which is the medium strength type and isn't necessarily permanent. You could conceivably break this free with a little bit of force. Then there's red Loctite, which effectively is permanent. Lastly, there's green Loctite, which is a retaining compound. This is used in situations just like this, where I have a snug fit and I need to make sure it isn't going to come apart. It's used a lot on bearings to make sure they don't slip on a shaft, and it comes in 2 varieties, one for press fits and one for slip fits. I only have the press fit type, but I think that's a better option here anyway because that is a really snug fit. When you use Loctite, make sure to clean all the oil and grease off of your parts. Chips that are magnetized to your part are totally fine though. Spread all that green goodness around and then slip the 2 parts together. This does wick down into the joint a little bit, so I can put some around the surface. There are other varieties that wick a lot more, so you can put it on screws and parts that are already installed. Once you're satisfied, just wipe off the excess. If we can all just look past how obscene this looks for a moment, this is my setup for drilling and tapping for the set screw. I'm finding the center of the part just like I've shown before. Then I'm spotting, drilling, and tapping the hole. Nothing earth-shattering here. I am drilling the hole into the column a little bit though. That'll make sure that it's being securely held by the set screw and won't back out. As you can see in this dramatic reenactment, I did this by moving the drill to the side of the part and moving it down to the depth I wanted. Then I set the quill stop to take the guesswork out of the situation. You can also see my other screw up on this part where I forgot that I had moved the table over to withdraw the boring bar and then engaged the feed while it was in the wrong spot. What can I say? I've got serious skills. I followed up with a bottoming tap by hand, and I put a small steel ball into the hole before installing the set screw. I did that because even with a bottoming tap, the threads won't go all the way to the end of the hole, and I wanted to make sure the column was held in place. The same thing could easily be done with a piece of brass or by cutting down the tip of the screw into a dog point. Let's move on to the shrink fit. This kind of fit relies on the fact that parts expand when heated and contract when cooled. I put the column in my freezer overnight, and then the next morning I heated the base in my kitchen oven to 425 degrees Fahrenheit, which just also happened to be the same temperature as the chicken nuggets I wanted for lunch that day. I let the base soak at that heat for a couple of hours to make sure it was hot throughout the part. Once everything was ready, I took the base out of the oven and set it aside. Then I pulled the column out of the freezer and it just dropped right in. Shrink fits let you slip two parts together that would otherwise require many tons of pressure to press together. This is a very effective way of assembling parts, but it can be pretty nerve-wracking because you only have one shot to get it right and you have to be quick about it. If the parts don't go together straight, you can pretty quickly find yourself with two parts stuck together at some weird angle. I rehearsed this process in my head several times before I did it. The parts start equalizing to temperature very quickly, so I wanted to make sure I had space to put everything and there'd be as little wasted time and motion as possible. I checked the fit as soon as the frost had stopped forming on the lower half of the column. The two parts are now effectively one piece of steel. This video is getting pretty long, so I'll wrap it up in the next video. If you have any questions or topics you'd like to see me cover in a future video, leave those down in the comments section below. Hit that like and subscribe button if you think I've earned it, and please consider supporting the channel over on Patreon like the wonderful people you can see on your screen right now. You might also want to check out these other videos as well. On the right, I have a playlist of all of my project videos. On the top left, I have my most recent video, and on the bottom left, there's a video YouTube thinks you'll enjoy as well. Thanks for watching. I'll see you next time.